A new telescope built to track fast-moving space objects in Chile has caught a comet from beyond the solar system moving across the sky.
A cosmic intruder just shattered our understanding of chemistry itself, releasing 8 times more carbon dioxide than any comet we've ever seen, and venting pure nickel gas in a pattern that shouldn't exist. According to Michio Kaku, the findings are nothing short of terrifying.
Visual sighting, infrared sensors, telescopic evidence. Now we have multiple sightings by multiple modes, and so the burden of proof has shifted.
At nearly 137,000 miles per hour, 3I/ATLAS is fast enough to escape the grip of any star. But what it carries is more than speed. It carries a message hidden in its chemistry, one that could force us to rethink the universe itself. The discovery. On the night of July 1, 2025, the Atlas telescope in Chile picked up a faint streak against the Milky Way. At first glance, it looked routine. Astronomers catalog smudges of light every night. But this one was different. The object was moving at an astonishing 137,000 miles per hour, fast enough to cross the United States from New York to Los Angeles in under 2 minutes. Nothing native to our solar system travels at that pace. At once, it was clear. This object wasn't ours. Observatories from Hawaii to South Africa quickly confirmed the readings. The numbers left no doubt. Humanity had detected only its third interstellar visitor, following the cigar-shaped mystery of Oumuamua in 2017 and Comet Borisov in 2019. Now, another name was added to that rare list, 3I/ATLAS, Third Interstellar. Its trajectory made the discovery even more remarkable. Unlike comets that loop around the Sun, 3I/ATLAS was on a hyperbolic path, slicing through our solar system once and then vanishing back into deep space. This was a one-time encounter, a chance that would not come again. To reach such speed, it must have been flung out of another star system long ago, perhaps during violent planet formation or a catastrophic collision. For billions of years, it drifted unseen. And now, by sheer coincidence, it had crossed paths with us. Physicist Michio Kaku called the data shocking, even terrifying. Not because Earth was in danger, but because the object's chemistry and trajectory pointed to processes we barely understand. A fragment from a world far beyond our own, carrying clues from deep time. The global astronomy community rushed to capture every observation before it disappeared. Every telescope, every sensor was aimed at the traveler. For Kaku and many others, it was a warning. 3I/ATLAS was not just another comet. It was a direct challenge to the way we thought the universe worked. Supersonic speed. From the very first measurements, one detail about 3I/ATLAS stood out above all else: its speed. Astronomers calculated its velocity at around 137,000 miles per hour, or about 58 kilometers per second. That number alone was staggering. Nothing native to our solar system moves quite like this. Planets, moons, comets, and asteroids all orbit in steady, predictable rhythms, bound tightly by the pull of the sun. But this visitor ignored those rules completely. It was fast enough not just to escape the sun's grip, but to cut straight through our cosmic neighborhood and never look back. To put that speed into perspective, consider this. A commercial jetliner tops out at about 600 miles per hour. The fastest rifle bullets travel at just over 3,000 miles per hour. Even NASA's Parker Solar Probe, the fastest spacecraft ever built, moves at roughly 430,000 miles per hour, but it does so only by repeatedly diving close to the sun and using its gravity as a slingshot. 3I/ATLAS, by contrast, didn't need a star's gravity to push it. It entered our solar system already moving at a pace beyond anything we can launch from Earth. If it could skim across our planet's surface, it would cross the United States from coast to coast in under 2 minutes. For scientists, This raised unsettling questions. How does an object reach such extraordinary speeds? One possibility is that it was ejected from its home system billions of years ago during the violent formation of planets, when gravitational interactions can fling debris into interstellar space. Another is that it might have been the victim of a catastrophic collision, hurled outward with a momentum strong enough to carry it across the galaxy. The point was clear. Whatever its origin, this object had endured forces on a scale we can barely imagine. That speed also carries energy. At its current pace, 3I/ATLAS holds an amount of kinetic energy that dwarfs human comparisons. If, by some astronomical misfortune, it were on a collision course with Earth, the impact would release more energy than the largest nuclear arsenal ever constructed. Thankfully, its trajectory is safe. It will pass through, making close approaches to planets like Mars, Venus, and Jupiter, but it poses no threat to our world. Even so, the thought that such raw, destructive power is drifting through our neighborhood unsettled even seasoned astronomers. It was a stark reminder of how small and fragile Earth is in a universe filled with forces far beyond our control. Yet what made 3I/ATLAS truly remarkable wasn't only its speed, but what that speed implied. If it could move this fast and remain on a hyperbolic path immune to the sun's gravity, then it was a messenger from elsewhere, a piece of a vanished system carrying clues about environments that might look nothing like our own. In other words, its velocity wasn't just a number, it was proof that the story of this object began far beyond our sight, in conditions that could rewrite how we think about cosmic origins. And just when scientists thought speed was the most astonishing part of the discovery, the chemistry of 3I/ATLAS delivered an even greater shock. Because when the James Webb Space Telescope turned its gaze toward the traveler, it found that the gases venting from its surface didn't match anything we'd ever seen before. The carbon dioxide mystery. When the James Webb Space Telescope turned its instruments on 3I/ATLAS, scientists expected familiar results. After all, comets are some of the most well-studied objects in our solar system. Their behavior follows a script. As they approach a star, the heat causes water ice to sublimate, releasing plumes of vapor that dominate their spectra. Alongside the water, smaller amounts of carbon dioxide and other gases usually appear. It's a pattern so predictable that it has served as the rulebook for comet science for decades. But 3I/ATLAS shredded that rulebook in an instant. The first full spectrum of the object revealed something no one had anticipated. Instead of water leading the outgassing, carbon dioxide completely overwhelmed the readings. In fact, the ratio was extreme, 8 times more carbon dioxide than water vapor. It was the highest CO2 to H2O ratio ever recorded in a comet-like body, far beyond anything seen in our solar system. For researchers, this wasn't just strange, it was unprecedented. The discovery immediately forced a wave of speculation. How could an object carry such an inverted chemistry? One possibility is that 3I/ATLAS was born in an environment colder than any region of our solar system, a place where carbon dioxide could freeze while water remained scarce. If so, it may have formed on the very outer edge of another star system, far beyond its equivalent of the Kuiper Belt. Another idea is that it formed closer to its star, in a region so hot that water was stripped away long ago, leaving carbon dioxide as the dominant volatile. Other explanations reach deeper into cosmic time. Billions of years adrift in interstellar space would have exposed 3I/ATLAS to radiation, cosmic rays, and even the shock waves of dying stars. Over millennia, those forces could have selectively eroded water from its surface, sculpting its chemistry into something entirely different. In that scenario, the object becomes a fossil scarred by galactic weather, carrying within it the memory of long-lost stellar events. Whatever the cause, one thing was undeniable. 3I/ATTLAS was not like any comet we had ever studied. Its chemistry told the story of a birthplace or a journey fundamentally alien to our own system. That raised unsettling questions. If a single interstellar visitor could carry such a radical signature, how many more exist with even stranger properties? And what does that say about the diversity of planetary systems across the galaxy? The neat categories astronomers relied upon, ice lines, volatile ratios, models of cometary formation, suddenly looked fragile. Michio Kaku described the data as shocking, even terrifying. Not because the gases posed a danger to Earth, but because they revealed how limited our understanding really is. For decades, scientists assumed comets across the universe would behave like those in our solar system. 3I/ATLAS demolished that assumption. Its alien chemistry was a direct challenge to the idea that our models could be applied universally. When telescopes probed deeper, looking not just at gases like CO2 and water, but at the metals venting from 3I/ATLAS, they found something even stranger. The chemical anomaly rattled astronomers, yet it was nothing compared to what the velocity revealed. Why this visitor matters. 3I/ATLAS isn't just rare. It's only the third interstellar visitor humanity has ever seen, after Oumuamua in 2017 and Comet Borisov in 2019. But its arrival proved something bigger. Our solar system isn't sealed off, it's porous. Debris from distant stars can, and does, cut straight through our neighborhood, carrying with it the chemistry of worlds we may never see. That realization turned 3I/ATLAS into a scientific emergency. Telescopes worldwide locked onto it within hours, racing to gather every spectrum, every image, every trace of data before the object vanished forever. Astronomers had lost their chance with Oumuamua. This time, they were determined not to repeat the mistake. And yet, beyond its rarity and urgency, one detail overshadowed everything else. It wasn't just that 3I/ATLAS existed, it was how it moved. Visitors from interstellar space are expected to be fast, but this one was faster than anyone imagined. Its velocity wasn't remarkable, it was unprecedented. Its motion broke expectations, but its metals broke something deeper, the very foundations of how elements are born. Nickel without iron? If the chemistry of 3I/ATLAS was already rewriting the rulebook, the metallic signatures pushed the story into even stranger territory. Observations from the Very Large Telescope in Chile picked up something clear and undeniable: nickel gas streaming from the object. Scientists have long known that as comets heat up, they can release traces of metals. Nickel, along with iron, is one of the most common, and the two are almost inseparable. They are forged together in the same stellar explosions, the supernovae that create most of the heavy elements in the universe. In meteorites and cometary dust, they're always found side by side, bonded like twins born from the same star. That's why what astronomers saw next was so jarring. Nickel without iron, not even a trace. The absence of iron was more than odd. It was unprecedented. It would be like finding thunder with no lightning, a split that simply shouldn't happen. For scientists, it was a sign that 3I/ATLAS had been shaped by conditions outside anything our solar system could produce. The timing of the nickel release didn't follow the normal script. In comets, lighter gases like cyanide are the first to escape when sunlight heats the surface. Heavier elements like nickel and iron only vent later, once the temperatures climb much higher. But 3I/ATLAS broke that sequence. Nickel appeared before cyanide. In simple terms, the heavy stuff was escaping before the light stuff, as if gravity itself had been reversed. Faced with data that defied every model, astronomers scrambled for answers. One theory suggested the nickel was trapped in exotic compounds, such as nickel tetracarbonyl, that vaporize at lower temperatures. Another idea proposed that cosmic rays, acting over billions of years, stripped iron from the surface while leaving nickel intact. Yet none of these explanations fit perfectly. Each had gaps. Each raised new questions. For Michio Kaku, this was another reason why the discovery was so unsettling. A comet-like body venting nickel without iron, and doing so on an inverted timeline, was not supposed to exist. If it did, then there were environments in the galaxy that operated by completely different rules. It wasn't just that we lacked answers, it was that we might not even be asking the right questions. And yet, the odd chemistry was only part of the puzzle. Because when astronomers mapped 3I/ATLAS's path through the solar system, its trajectory looked no less peculiar than its composition. The improbable trajectory. If the speed and chemistry of 3I/ATLAS weren't enough, its path through the solar system added a whole new layer of intrigue. Harvard astronomer Avi Loeb, who famously stirred debate over Oumuamua, ran the numbers on its trajectory. What he and his team found was nothing short of astonishing. The interstellar visitor wasn't drifting aimlessly. Its course was calculated, threading the orbital plane of the planets, sweeping past multiple worlds with uncanny precision. On October 3, 2025, 3I/ATLAS is expected to swing within just 18 million miles of Mars. Only weeks later, it will pass within 60 million miles of Venus. By March of the following year, it will glide 33 million miles from Jupiter. For astronomical distances, these are razor-thin margins. Each pass is a near miss on a cosmic scale. The odds of an interstellar object aligning so closely with not one but 3 major planets in succession? Loeb estimated them at 0.005%, or roughly 1 chance in 20,000. It's the kind of statistic that makes even seasoned scientists sit back and wonder if the universe is playing dice, or if something deeper is at work. The resemblance to planned spacecraft maneuvers didn't help calm the unease. When mission planners at NASA want to boost the speed of probes like Voyager or New Horizons, they rely on gravity assists, slingshotting around planets to steal momentum and rocket outward. The trajectory of 3I/ATLAS looked eerily similar to such maneuvers. Was it coincidence? Almost certainly, most astronomers argued, but the precision unsettled many nonetheless. Then came the matter of timing. As 3I/ATLAS makes its closest pass to the Sun in late October 2025, it will be hidden directly behind the Sun from Earth's vantage point. This means, just as the object reaches peak activity, its brightest and most dynamic phase, it will vanish from our view. No ground-based telescope will be able to track it. The timing struck many as frustrating, but also strangely convenient, as though the universe had placed a curtain between us and its most important act. NASA confirmed this perihelion geometry as fact, but it didn't stop speculation from filling the gaps. Scientists remain careful about what they say. Most insist the trajectory is simply a product of random chance and gravitational influence. But the improbability, the tight alignments, and the veil of the sun's glare all fuel a sense of mystery that even experts struggle to dismiss. Was this just the chaos of celestial mechanics, or something we haven't yet begun to understand? And perhaps more importantly, what does such a path remind us of? For centuries, comets blazing across the sky were treated as omens, symbols of doom or change. Now, with the data of modern astronomy, we can measure trajectories and calculate probabilities. But deep down, the unease is still there. Because when an alien object threads its way through the planets with impossible precision, It echoes the same fear that has haunted humanity since the first comet appeared in ancient skies. A relic older than Earth. As scientists traced the orbit of 3I/ATLAS back through space, the clues grew stranger. Using the Gaia Star Catalog, a map of more than 1 billion stars, they compared its motion against the backdrop of the Milky Way. The results pointed toward the galaxy's thick disk, a region filled with some of the oldest stars ever formed. The thick disk is sometimes called the Milky Way's retirement home. Its stars can be 10 billion years old, more than twice the age of our Sun. If 3I/ATLAS truly came from there, then it may have been wandering interstellar space for 7 billion years before arriving here. While Earth was still a cloud of dust, this object was already drifting across the galaxy, carrying with it the remnants of a vanished system. Its chemistry reinforces that sense of age. The extreme carbon dioxide ratio, the missing iron, the inverted gas sequence, all may be scars from eons of exposure to cosmic rays and radiation. Every particle is a memory, a fragment of a world that no longer exists, preserved in this traveler from another age. What makes this even more extraordinary is timing. For billions of years, 3I/ATLAS passed unseen through the galaxy. And yet, by chance, it crossed paths with us at the exact moment humanity had the technology to notice it. Out of all the centuries it could have appeared, it arrived now, when our telescopes could finally catch its light. For humanity, the symbolism is humbling. To witness a body that began its journey before our planet even formed is to be reminded how brief our history is beside the scale of the cosmos. 3I/ATLAS is not just a visitor. It is a relic, a messenger from the Milky Way's youth, crossing our path by chance and offering us a fleeting glimpse into the deep past. But the question remains, what do we do with that knowledge? What does a relic older than Earth mean for us now, as a species standing at the edge of understanding? For decades, scientists believed the chemistry of comets followed universal rules. 3I/ATLAS shattered them. Its alien chemistry shows that the building blocks of planets and stars aren't fixed. They can change from one system to the next. Michio Kaku called the data terrifying, and he's right. Because if the very recipe of matter itself can differ so wildly, then everything we think we know about how worlds are born is incomplete. And if one interstellar visitor can overturn so much, how many more are out there, waiting to prove that our understanding of the cosmos has only just begun?